Assalamualaikum and selamat sejahtera. My name is Rabi Abdul Adawiyah binti Zawadud. Metric number H20E1721. Firstly, I will present about the data arrangement of the sample data from Appendix 1 that we choose, that is the labor force by age group in Selangor 2000 until 2005. In order to arrange the data, we need to select a random n bigger than 50. So the sample selected random of the labor force by age group in Selangor 2000 to 2005 is 60. It is because 60 bigger than 50. The first step of data arrangement is decide on the number of classes. A useful way to determine the number of classes k is the 2 to the k rule, such that 2 power of k bigger than n. There were 60 labor force by age group 2000 to 2005. So n equal to 60 if we try k equal to 5, which means we will use 5 classes. Then 2 power of 5 equal to 32, somewhat less than 60. Hence, 5 is not enough classes. If we let k equal to 6, 2 power of 6 equal to 64, which is greater than 60. So the recommended number of classes is 6. Step 2. Determine the class interval of width. Class width equal to maximum entry minus minimum entry divided by number of classes. So we get 379.7 minus 17.6 divided by 6 equal to 60.35. 60.35 round up to 61. Step 3. Set the individual class limits. The minimum data entry is a convenient lower limit for the first class. To find the lower limits of the remaining 5 classes, add the class width of 61 to the lower limit of each previous class. The upper limits of the other classes are 78.6 plus 61 equal to 139.6. 139.6 plus 61 equal to 200.6, and so on. Step 4. Make a tally mark for each data entry in the appropriate class. Step 5. The number of tally marked for a class is the frequency for that class. This table is the example of frequency distribution of group data. In this slide, the table shows how to find the relative frequency. Next, in this slide, the table shows how to find the cumulative frequency.
Okay, now I'm going to present about graphical method. In graphical method, we use graph bar and line. In the first table, we calculate lower class boundary, upper class boundary, midpoint, and frequency for each class. So, in the bar graph, we want to know about frequency and midpoint. As we can see, the bar graph is shown the higher frequency in midpoint 78.6, it is 24 frequency, and the lower frequency in midpoint 414.6, it's 0 frequency. Okay, next, in this table, we calculate upper class boundary, frequency, and cumulative frequency. So, in this line graph, we want to know about cumulative frequency and upper class boundary. Okay, for the 140.1 upper class boundary, have the lower cumulative frequency, it is 24 cumulative frequency. Okay, next, for the upper class boundary 384.1 and 445.1 have the same cumulative frequency, it is 60.
My name is Siti Natira binti Nazari, metric number H20A1792. The measure of central tendency, mean, this is the mean, median, and mode formula. And the total of mean is 190,700. The median, step 1, total is 30 observation, and step 2 is 201.1. Step 3, 61. Step 4 is FM1 is 30 and FM is 11. For step 5, the total is 201.1. For the mode, step 1 is the modal class is 262.6 till 322.6. For step 2 is 262.1. Step 3 is 61. Step 4, tangent 1 is 12 minus 11 equal 1, and tangent 2 is 12 minus 7 equal 5. Step 5 is 299.4. So the mode of the labor force by age group in Selangor is Selangor 2000 till 2005 was approximately 299.4. Measures of variation. The range is 367 and the variance is 10,704.25, and the standard deviation is 103.46. Therefore, the sample of standard deviation is 103.46 labor force age. Measures of position. For step 1, the class interval for Q1 is 17.6 till 139.6, and Q3 is class interval is 262.6 and till 322.6. For step 2, LM is 17.1 and class size is 1 to 3. Q1 is 58100. Therefore, the value of is 58.1 or 58,100 labor force age. Q3 is 610.6. Therefore, the value of 610.6 or 610600 labor force age. Next is interquartile range. The difference between the upper and lower quartiles is called the interquartiles range. So the total is 552,500. Therefore, the value of interquartile range is 552.5 or 552,500 labor force age. And last is shape of data distribution. The shape of a distribution is described by its number of peaks and by its possession of asymmetry. Mean is 190.7 or 190,700 labor force age. Median is 201.1 or 201,100 labor force age. And the mode is 299.4 or 299,400 labor force age.
Then it goes a little something like
Assalamualaikum and hi, my name is Nurul Natasha binti Muhammad Maliki and my metric number is H2081691. Today, I will present number 1 in part B. Number 1 is about find one set of data that have one independent variable and one dependent variable. This is data that have we get. B performance when we have two variables, one dependent variables and one independent variable. For example, we have a data set where the income of various car dealer is provided along with the number of cars sold. Here our dependence income, while the independence variable is sales, shown in the table.
Assalamualaikum and hi, my name is Rabiatul Adawiyah binti Badrul, metric number H20A1719. I would like to present part B of question number 3. Before I forget, the sample for our data set is N32. Question 3 reads, compute the person's product moment correlation coefficient, then explain the value obtained. Calculate manually. Okay, first we calculate the data x and y to know x square, y square and xy. After that, just calculate the sum the each column, namely column x, column y column x square, column y square, and column xy. So we will get the sum from the count. Total of summation x 3,345. Total of summation y 9,094. Total of summation x square 432,275. Total of summation y square 2,646,404. Total of summation xy 1,008,075. This is our solution. Here we use this formula. R means correlation coefficient. Okay, the amount we get from summations x, y, x square, y square, and xy. Just put it into the formula. After that, calculate it. This calculation manually. Lastly, the answer we get is 0.79. So there is strong positive correlation.
Hi, my name is Muhammad Ashraf Ridwan bin Mazami, metric number H20A1264. So I will explain the last part of section B, which is how to calculate estimate regression equation. In this slide, we will see the formula how to calculate estimate regression equation. So y equal BO plus B1x. So how to get B1 is sum of xy minus sum of x multiply sum of y divided n and divided by sum of x power of 2 minus in bracket sum of x multiply power of 2 divided n. 1008075 minus 3345 in bracket 1994 divided 32 and divided by 434275 minus in bracket 3345 power of 2 divided 32. So we will get the answer is 0.680. For BO is y minus B1x. 200 minus 0.680 in bracket 5. So we'll get the answer is 196.6. Next, regression equation. In the previous slide, we have calculate estimate regression equation already. So y is we get 196.6 plus 0.680x. Slope B1 is 0.680. That means for every one cell increase in number of cars sold, the income will increase above 0.680 ringgit measure. For constant, B0 is 196.6. That means when the number of cars sold is 0, the income of car dealers is 196.6 ringgit measure. Because the slope is 0.680, it may be determined that x has a 0.680 contribution to the y. The basic y is 196.6. That's all our presentation group. Thank you.